Welcome to the session 6 of the memory system. In today's session, we'll study about synchronous DRAMs. In short, the synchronous DRAM is called as SDRAM. The synchronous DRAM is the commonly used name for various kinds of dynamic RAMs that are synchronized with the clock signal. That is, all kinds of a dynamic RAM which are synchronized with the clock signals are called as synchronous DRAMs. So by the year of 2000, all kinds of dynamic RAMs were replaced by a synchronous DRAM. The structure of the synchronous DRAM is similar to that of the asynchronous DRAM. So now let us study the internal organization of the synchronous DRAM chip. So as I told that the synchronous DRAM is similar to that of the asynchronous DRAM, where the row and the column addresses are provided. Here the row address latch is connected to the row decoder, which is used to select a particular cell in the cell array. So then we having a column address counter instead of a column address latch, which is connected to a column decoder, which is used to count the next column for the faster access. So here then we having a read-write latch, which is connected to the data input register and the data output register. So then why we need the data input register and data output registers? So whenever we want to transfer a data from a data bus to a particular cell, we need a data input register. So that is, the data input register is required to transfer the data from a data bus to a particular cell in the cell array. Then whenever we want to transfer a data from a particular cell of a cell array to a data bus, then we can make use of a data output register. That is, a data output register is required to transfer a data from a particular cell of a cell array to the data bus. So in synchronous DRAM, it is having one more module called as a mode register and a timing control, where the clock signal has provided. The mode register will going to operate the chip, or it makes the memory chip to be operated in different modes. So for the mode register, the clock signals are provided. Along with the clock signal, the RAS signal is provided. That is, a row address select signal is provided. Then CAS signal is provided. That is, a column address select is provided. Along with these three, so we are having a read-write control signals, and the chip select signal is also provided to the mode registers. So along with all these modules, we having one more additional module called as a refresh counter. The synchronous DRAM is having a inbuilt refresh circuit with this refresh counter, which refresh the cells of a row periodically. So as I told that the structure of SDRAM is similar to that of the asynchronous DRAM with some features. That is, it is having a refresh counter to refresh the cells of a row periodically. Then it is having a column address counter instead of a column address latch in order to generate the required signals. Then the read-write latches are connected to the data input registers and the data output registers. Along with that, we having the mode registers, which can be set in order to perform various operations, or the chip can perform operations in different modes. So along with that, the output of a sense amplifiers are connected to a latch here. So now let us see how a read and write operations can be performed in a synchronous DRAM. So in order to perform the read operation, the row address is applied. In response to the column address, the data present in a latch for the selected column are transferred to the data output register, and from the data output register that will be transferred to a data bus. Then the data is available on the data bus. So in order to perform the write operation, the row address is applied first, and in response to the column address, the data present on the data bus is made available to the latches through the use of the data input registers. Then the data will be written to a particular cell in the cell array. So now let us see the timing diagram for the burst read of length 4 in asynchronous DRAM. So here first the row address will be latched using the RAS signal. The memory typically takes 2 or 3 clock cycles in order to activate the selected row. So in this diagram we have shown 2 clock cycles in order to activate the selected row. Once the row has been activated, then the column address will be latched using the CAS signal. Then after the 1 clock cycle, the first word of data will be placed on a data bus. And in the remaining clock cycles, the remaining 3 word of data can be placed on a data bus in a consecutive 3 clock cycles. So that is, first the D dot will be placed on a data bus. Once D naught has been placed in the next 3 consecutive cycles, so we can place the remaining 3 words on a data bus. So then, in order to measure the performance of the synchronous DRAM, 2 parameters are defined. One is the latency and another one is the bandwidth. A memory latency is the time it takes to transfer a word of data to or from the memory. So that is, in case of the burst operation that transfers a block of data. In timing diagram, as I told that first we need to activate the row. The row address will be latched using the RAS signal. So that is, the access cycles begins with the assertion of a RAS signal. Then the first word of data is transferred after the 5 clock cycles. So we can see that the latency is 5 clock cycles. The remaining 3 words are transferred in the next 3 consecutive clock cycles. So then the synchronous DRAM will going to perform all its actions on the rising edge of a clock cycles. Another parameter which is used to measure the performance is the memory bandwidth. A memory bandwidth is the number of bits or the bytes that can be transferred in 1 second. That is, how many number of bits or bytes are transferred in 1 second. So in order to improve the performance of a synchronous DRAM, a faster version of synchronous DRAM has been provided. We call it as a double data rate SDRAM. In short, it is called as a DDR SDRAM. So in order to provide the faster version of a synchronous DRAM, a similar memory device is made available where the cell array can be accessed in the same way, but in order to transfer a data, the data will be transferred on both the edges of the clock cycles. That is, whenever we want to transfer a data can be transferred both on the rising edge as well as on the falling edge of a clock cycles. So in double data rate SDRAM, so accessing the cell array is similar to that of in the SDRAM, but while transferring the data can be transferred both on the rising edge as well as on the falling edge of a clock cycle. So because of that, the latency remains the same, but the bandwidth will be double. Hence the name, the double data rate SDRAM. So in order to provide such a facility for the double data rate SDRAM, the cell array will be organized with two banks, where the two banks can be accessed separately so that the two words can be transferred both on the rising edge as well as on the falling edge of a clock cycles. So this is about today's session, and regarding today's session we having some of the multiple choice questions. In that, the first question is, the SDRAM performs operation on option A, the rising edge of a clock, option B, the falling edge of a clock, the option C, the middle state of the clock, and the option D, the transition state of the clock. So as I told, the synchronous DRAM will perform all its actions on the rising edge of a clock signal. So answer is A, that is rising edge of the clock. The next question, the time taken to transfer a word of data to or from the memory is called as the option A, access time, the option B, cycle time, the option C, memory latency, and the option D, none of the above. The time taken to transfer a word of data to or from the memory is called as a latency. So the option is C, that is memory latency. The next question, the DDR SDRAM performs the faster data transfer by option A, integrating the hardware, option B, transferring on both the edge, option C, improving the clock speed, and option D, increasing the bandwidth. The DDR SDRAM will perform the faster data transfer by transferring the data on both the rising edge and the falling edge of a clock cycle. So option B, that is transferring on both the edges. The next question, using DDR SDRAM, the bandwidth is decreased. Option B, the bandwidth is doubled. The option C, bandwidth remains the same, and option D, none of the above. So by using the DDR SDRAM, the bandwidth will be double. Hence the name we call as a double data rate SDRAM. So answer is the option B, the bandwidth is double. So this is about today's session. Thank you.